Hello everyone, myself Yadagiri, Faculty of Basic Electrical Engineering, MLR Institute of Technology, Hyderabad. So in this session, we have to discuss about the procedure about the Thevenin theorem. So before going to commencing the procedure about the Thevenin theorem means, so first of all, what does it mean by Thevenin theorem? So the Thevenin theorem is a kind of network theorem, so which is used to apply this kind of theorem to the any kind of complex circuit to get the again response quickly. So that is similar to the superposition theorem only, but there will be changes in the Thevenin theorem compared to that one. So that is, so this Thevenin theorem is purely applicable for again linear bilateral elements only. So it is simply states that so in any kind of network or circuit, so having the more number of independent sources and the more number of passive elements. That means, so if in any linear bilateral two terminal network consisting of the more number of active elements and also the more number of passive elements. So the whole network can be replaced by an equivalent circuit consisting of the single voltage source. So that is called simply Thevenin or Thevenin voltage source, and all remaining passive elements can be simply replaced by single resistor, that is called Thevenin. So that is a statement of the Thevenin theorem. So the Thevenin theorem is simply states that in any linear two-terminal bilateral network consisting of the more number of active elements and the more number of passive elements, so the whole network can be simply replaced by an equivalent circuit consisting of the one voltage source, that is a Thevenin, so which in series to the one passive element, that is a Thevenin, and one resistor, that is called Thevenin. Both are in series to each other. So this is the statement of the simply Thevenin theorem. So any kind of complex circuit we can simply replace it by like a single source network. That is the Thevenin theorem is stating us. So according to that, how can we replace with the whole network? Can be this kind of big network, can be this symbol network means. So there is a certain procedure. So in the procedure, so we have the different steps. So in the step number one, we need to get this value. So how can we get this? So VTH value. In the step number 2, then how can we get the other one, that is the RTH value. So then the step number 3, so how can we draw the Thevenin's equivalent circuit? So based on these two values only, we need to draw the Thevenin's equivalent circuit. So this is the Thevenin's theorem. So now let us discuss about the what kind of procedure involved to get this kind of Thevenin's equivalent circuits. So here first we need to take this kind of network. So this is having this one voltage source. This is R1, R2, R3, and this is the RL value, load resistor value. So we can simply replace this whole network with the this kind of whole network with the Thevenin's equivalent circuit. That is, it has only one voltage source as VTH, and which in series to single resistor called as RTH. So single resistor, that's called RTH. Instead of R1, R2, R3, we can simply replace it by RTH. And there is a procedure to get the VTH and also the RTH. So first let us go with the how to get the VTH value. So this, how can we get the VTH value means, so we can simply go through the same circuit here. So this circuit, having like this, the voltage source 1 and R1, R2, R3, and here RL. So to determine the VTH value of the above network, so we can simply disconnect the load resistor. So whatever the element we need to get the response, that we can simply replace it, simply remove it from the corresponding terminals. So that we can consider as a load resistor. So that we can simply remove the load resistor. Means what I want to say means here, so we need to get the Thevenin voltage value of any circuit. We can simply remove the load resistor value. So which can be simply open circuits. So whatever the voltage we got across these two open terminals points or open terminals, so that corresponding voltage is called as the Thevenin voltage. So we need to get the voltage across the open circuit terminals. That's why that voltage is also called as the open circuit voltage. So how can we get the voltage means? So the voltage given by the voltage source, then how much voltage appear across these 2 points, that we need to find. That voltage is called as the Thevenin voltage. So how can we means? First we need to find out the current through the whole network. So before going to that, so this R2 element is connected the open terminal. So that it used to lost their property. I mean the R2 element lost their original property to resist the flow of current. That's why. So there is no element connected over this entire path. So whatever the circuit drawn here, so which is similar to this only here. So voltage source value is a Vs, and this is a R1 resistor, and this is a R3 resistor, and this is so empty path. So this is the terminals are A, B only. So because so there is a R resistor here, so that lost their property. That's why we can simply replace the corresponding element is a simple line. So then the whatever the voltage we got across these 2 points, that is VAB terminals. So that voltage is called as Thevenin voltage. So we need to get the voltage across the open circuit terminal. That voltage is called as the open circuit voltage. So how can we get the voltage across that terminal means? So we need to find out the voltage across this element, that is R3 resistor. Then the corresponding voltage is also called as Thevenin voltage. I mean, so this voltage and also these 2 point voltage are same because there is no potential drop between. So these 2 points to here. So that's why we need to find out the current flow, the voltage across the R3 resistor. So for that we need to find out the current of the network. So according to the Ohm's law, that is I equal to formula is a V by R. So that means V divided by, so R is a R1 plus R3. Why? Because whatever the current given by the voltage source, so that should be circulating towards this path only. So that like that we will get the current through this element. The whole network is a, so that is I only, means current through R1 and also R3 is the same only. So both are in series. So that R equivalent of this whole network is a V by R1 plus R2. So this is the way to get the total current of the circuit. Then we need to find out the current flows through the R3 element, that is a V3 ohms equal to then I into then R3 value. So what is I value here? I only we got according to this one. What about the R3 value? This is R3. So this the V3 ohm resistor value. I mean voltage across the R3 resistor value. So whatever the voltage we got here, the same voltage is a VTH value. That is VTH, also V open circuit, also V3 ohms equal to I into R3. So this is Thevenin voltage value. Also there is other method to get the VTH of the circuit because it's a series element. So there is a the technique we need to apply. So to get the voltage across this element, that is voltage division rule. According to the voltage division rule, so we need to get the voltage across this R3 resistor. So that is voltage division rule. From voltage division rule, so the voltage across the R3 element equal to the total voltage of the circuit into same resistance divided by the total distance. So according to that also we need to find out the voltage across this element. So that corresponding voltage is called as the Thevenin voltage. So this is the procedure to get the VTH value. So while calculating the VTH or open circuit voltage of the any circuit, we can simply remove the load resistor from the load terminals, and the corresponding terminals are keep open, and whatever the voltage we got across that 2 points, that voltage is called as the Thevenin voltage. So that we have done according to this method and also according to this method. So both are same only. Then after that, next step, I mean to draw the whole network, the whole complex network with the single source network. So for finding out the VTH and also the RTH, then only we can simply draw the this big network into the simple network. So in that we have done about the VTH, and the remaining one is a RTH value. So there is a certain procedure to get the RTH of the network. So means we can determine the RTH of the Thevenin resistance of the any network. We can simply remove the load resistor from the load terminals and also disconnect the all kinds of sources. So if it is a voltage source present in the network, so we can simply replace it by short circuit path. If it is a current source in the network, we can simply replace it by open circuit path. So here open circuit path. So current source, if it is a voltage source, we can simply short circuit. If it is a current source, we can simply replace it by open circuit path. So here in the network, there is a presence of voltage source. That's why we can simply replace it. The corresponding source should be short circuit path. Actually, we need to replace that kind of sources can be by their internal resistance actually. But here there is no internal resistance of this source, so that we can simply replace it by the short circuit path. Then the corresponding resistance between the open terminals should be, so here So equivalent resistance one means need to find out the series and parallel combination. For that, assign a dummy source here and that delivers some current. The current is traveling towards the R2 and divide between these two. So based on this one, so here R1 and R3 are in parallel and the combination is in series to R2. I mean R1 in parallel to R3 and the whole combination is in series to R2. So therefore, R equivalent of above circuit is a R1 into R3 upon R1 plus R2 plus R2, sorry, R1 into R3 upon R1 plus R3. So plus R2 keep as it is. I mean this combination is in series to R2. So this is the corresponding resistance value. So this open circuit resistance also called as the Thevenin resistance. So the R equivalent of this combination is also called as RTH, also called as the ROC. ROC means open circuit resistance, that is R2 plus R1 into R3 upon R1 plus R3. So this is the Thevenin resistance value. So we have done the two steps, I mean two different parameters to get the VTH and RTH of the circuit. VTH we have done and also the RTH we have done. So we can easily draw the equivalent circuit. So the equivalent circuit, the step number 3 is we need to draw the Thevenin's equivalent circuit. Thevenin's equivalent circuit with the RTH and VTH. So here VTH and also the RTH, which is in series to the, so the both I mean each and every one. So then after that we have seen, we have earlier case we have removed the load resistor. So that is simply attached here. So we got the equivalent circuit should be like this. So this is the Thevenin voltage source is a VTH and the Thevenin resistance is the RTH. So here these are the open terminals or load terminals. We can connect the load resistor here. So whatever the resistor we have removed in the earlier stage, so that we can connect here. So that corresponding element is the RL value or RL element. So then find out the load current value. So by using this one, need to find out the current through the load resistor, that is according to the Ohm's law, V upon R. So what we here, VTH only, VTH upon R means, so we have the both resistor, that is RTH plus RL. This is the way to get the current through the load resistor. So this is about the Thevenin's theorem. Summary of this session means, so in this session we have till now discussed about the statement of the Thevenin's theorem, and how to get the VTH of the circuit, so and how to get the RTH of the circuit. So statement means how can we deal this theorem means, if the any kind of complex circuit having the more number of active elements and also the more number of passive elements, so the whole circuit can be simply replaced it by an equivalent circuit consisting of the single source. I mean that is single source only. So that all that are having simply single source, that is single voltage source. So which in series to the single resistor, that is called RTH. So this is the statement of the Thevenin's theorem. And how to get the VTH? VTH of circuit means, so how can we get the VTH means, we can simply remove the load resistor from the load terminals and corresponding terminals are give some voltage, that's called VTH. And RTH means, so we need to simply remove the all kinds of any sources present in the network and also remove the load terminals. So whatever the load terminals are given some resistance of their equivalent value, so that corresponding value is the RTH value. So then after that, so we need to draw the Thevenin's equivalent circuits, Thevenin's equivalent circuit with the help of VTH and RTH. So this is a VTH, this is the RTH, so that is a VTH, then RTH, and in the earlier stage we have removed the load resistor, so that we have to connect here or join here. Then by using this one, need to find out the required element voltage and current value. So that is IL equal to the VTH upon RTH plus RL. This is according to Ohm's law. So VL also we can get by using this one according to Ohm's law, IL into RL. So this is the summary of this on the entire session. So in the next, thank you and all. Thanks for watching this one. In the next session, we are going to discuss about the Norton theorem and how to apply the Norton theorem to the complex circuits and also the maximum power transfer theorem. So thank you and all, and thanks for watching.